Okay guys, let's take a look at today's lesson. We have some more formulas. Yay! You're probably thinking, gosh, I don't have enough formulas. Now we have more. So let's take a look at these formulas. I want to give you just a moment as I am talking to you about them to copy these on your gold sheet. We are going to be talking about two different kinds of product to sum formulas and formulas for lowering powers. Those are the two that are our topic for today. So let me explain the importance of these kinds of formulas and why we're learning them. So maybe that, maybe it will or maybe it will not help you. These are very important to us in calculus, and actually more specifically in calculus 2. So in AB calculus, we cover just calculus 1 semester of college calculus. In BC calculus, we cover 2 semesters, calculus 1 and calculus 2. And these formulas are critical in calculus 2 for integration. We need them and we will use them because it is quite difficult to integrate a product unless it's formatted a specific way. So when we have this kind of situation come up, it is very helpful for us to be able to write it as a sum. Big deal for us in calculus. Way easier to integrate independent things separated by pluses and minuses than a product. So that's the benefit of this formula, is we will use it to switch from a product to a sum. So pretty important. This other formula right here for converting sine squared, cosine squared. Again, in calculus, it's quite difficult to integrate something squared unless it's set up perfectly. It's quite difficult. And so instead, we're going to switch it to a double angle. It's easier to integrate a double angle than it is something squared. And that's something that you'll learn in calculus next year. I had a student ask me earlier, are we going to be integrating? No, we're not going to be integrating in Precal. We're learning the formulas, how to use them, so that when you get to them in calculus, you'll be like, oh yeah, I remember that, I got that. I know how to do that. And so that's really the premise or the reason why we're learning these formulas. So let's talk about them. The patterns to hopefully help us remember how to memorize the formulas. We'll look at these sine, cosine ones first. So they're the same, right? Sine one angle times sine of another, cosine one angle times cosine of another. In those formulas where they're identical, it's only cosines. Of course, you would expect, right? We know the temperament of cosine, right? So if it's cosine times cosine, of course it's going to take over. It's going to be cosine. And if it's sine times sine, it's probably really upset that it didn't get to play, so it's going to take over and be cosine. Now, if it's mixed, notice how it matters which comes first, the sine or the cosine. It changes the formula depending on which one comes first. You can't just arbitrarily switch them and it come out the same way. It won't. It's going to change the formula. So here, if sine comes first, well, basically on both of these mixed, sine, cosine, sine, notice how it's sine. There's sine in the formula. Okay? Within the formula is just one trig function. There's no mixture within the formula. No mixture. It's sine, or cosine. So looking at these the sine, cosine, and cosine, sine, well, the difference between these two is one is adding and one is subtracting. So that's the difference between the two of them. The difference down here with the cosine, sine, again, this is a sum or a difference. I also want for you to note that for the sums, it doesn't matter what order you get these two in. You can have the u minus v or the u plus v. It doesn't matter the order, right? Because when we're adding, it doesn't matter what order we're adding it in. But for the subtractions, this makes a big difference. This one needs to come first for the subtraction ones. Okay? So just kind of a note as you're going through memorizing them, the things that hopefully may help you memorize those formulas. So let's look at these two sets over here, formulas for lowering powers. So we have sine squared and we have cosine squared. I'm not really worried about tangent squared, because if you know the sine squared, cosine squared, can't you come up with the tangent squared? Right, it would just be this one over this one and turns into that one. It's just, right, it's not. There's no extra memorization for the tangent squared. It's just these two that we're concerned with. Notice how they look almost exactly alike. Cosine is taking over, right? It doesn't matter if it's sine squared or cosine squared, it's cosine. The only difference between these two formulas is the sign here. This is a subtraction, this is an addition. So of course it's not really turning out how I would have envisioned it. The nicer one, I thought sine should get the plus, but of course that's not the way it is. Cosine is the one that gets the plus and sine gets the minus. Okay, but the formulas are the same. Sometimes I've seen students, and I do it too sometimes, write the formula like this. For some, it's easier to memorize this way with the half times 1 minus cosine 2x, or, you know, the half times 1 plus cosine 2x. Kind of just depends on how you want to memorize it. If we're integrating, it's probably easier to integrate using this formula because we would just pull the constant outside, but that's for next year. Okay? So, questions about the formulas themselves. Okay, so let's practice. Let's practice with each of these. Of course, I'm not going to be able to do all. Let's practice one of the product of sum and one of the lowering power ones. Okay. So, we're going to express this product as a sum. And again, the reason we do this is because it's really difficult to integrate a product. It's much easier to integrate a sum, so that's why we use it. So I'm going to write the formula. So this is a sine one. So I'm going to write the formula up above so we can watch as we plug into it. So we have cosine u minus v. By the way, the first angle measure is u and the second angle is v. And then we have minus cosine u plus v. Okay, so there's our formula. That's what we're plugging into. Okay, so let's start. So we are just using the formula. Don't need to write any reasons. We're just using the formula. So we have cosine of 3x minus 5x minus, I'm just plugging into the formula, cosine of 3x plus 5x. Okay, so now it's just a matter of simplification. So let's keep working. So I have cosine of negative 2x minus cosine of 8x. I would actually like to do one more thing, and I would like for you to do this as well. If you have a negative angle, I would like for you to use the even-odd property and fix it so that it's not negative. So the even-odd property for cosine, we remember that hopefully, right? And so that would give us 1/2 cosine 2x minus cosine 8x. And that's our final answer. And that's all we need to do. Could you distribute the 1/2 if you wanted to? Sure. But it's not necessary. We can just leave it like that. So the product to sums are pretty easy. They're just plugging into a formula and simplifying. That's all. Are we okay with that? Okay, the squared ones are a little bit more challenging. Just a little bit more challenging. So what we want to do is we want to get everything down to a power of 1. That's what we want, is a power of 1. And so, and again, the reason is it's easier to integrate things with a power of 1 than it is with a power of 2 or a 4 or whatever. So what we're going to do is we're going to rewrite these using the formulas from the previous page. Let's rewrite them. So sine squared x cosine squared x is going to be the same as. Okay, so let's rewrite. So sine, that one gets the negative one, right? So 1 minus cosine 2x over 2. And cosine gets the positive one. 1 plus cosine 2x over 2. Okay, that's great. We do have them as not squareds. They're individual. But of course, it's still a product. We can't leave it like that. We're going to have to FOIL it out. And so let's do that. I'm going to take the fraction and I'm going to pull it out front just for simplicity's sake. I just don't want to deal with it. I just don't want to continue to multiply by a half. So now these are conjugates, so 1 times 1 is 1. Then I would have plus cosine 2x minus cosine 2x, that cancels out. Then I have minus cosine squared 2x. Oh darn, we have a squared again. Not okay. We need to continue on with our formulas until we eliminate all of the squares. So, we have a couple of options here. I'm going to go ahead and distribute the 1/4 so we can deal with the cosine squared by itself instead of trying to deal with it inside of the parentheses. So let's just go ahead and distribute the 1/4. You know, this 1/4 is not going to be part of our work on the cosine squared, right? It's separate. So I'm going to take this part and I'm going to use my formula. Now let's talk about the formula. Let me write one of them up here. So we know cosine squared is the same as 1 plus cosine 2x over 2. The original squared has a single angle, doesn't it? And it turned into a double angle. What do you think is going to happen when I use this formula on something that's a double angle? What do you think it's going to turn it into? Yeah, to 4. It's going to turn into 4x. Because what happened here, this doubled, right? When I use the formula, the angle doubled. So I'm going to use the formula and the angle is going to double. It's going to go to 4x. What if this were a 4? What would it go to? It would go to 8x. We really need to keep that in mind. Okay, don't just blindly use the formula. We need to understand what's happening in the formula. These single angles, whatever angle it is going to be doubled. If this were a 3, it would be 6, right? It's going to be doubled, whatever angle measure is there. Okay, so I just wanted to be sure we were clear. So I'm going to open up this. I'm going to replace cosine squared 2x with that, use that formula again. I'm going to use the formula in this way, 1/2 1 plus cosine 2x. Okay, I mean, it's not going to be a 2, right? We know it's going to be a 4, but I'm going to use it this way. So here's my 1/2, right, for my formula. It's for my formula. And then I have 1 plus cosine, what? It's going to be cosine 4x. Okay? So we're kind of happy. We don't have any squareds anymore. This is a great feeling, right? We're in first powers. But if I were to try to integrate that is a mess. I just need to clean it up. It's really just cleanup time. Let's just clean it up, make it as small as possible. So I have 1/4. So these three are being multiplied together. So I hope you're okay if I multiply the -1/4 times the 1/2 and get a -1/8, right? And then distribute. I'm going to do that all in one step. Hopefully that's not too disturbing to us. Are we okay? So it's going to be -1/8 times 1 is -1/8. -1/8 times cosine is -1/8 cosine 4x. Okay, do we have some like terms we can combine? Yes, right, the 1/4 and the 1/8. So let's think of this as 2/8 minus 1/8. 2/8 minus 1/8 would give me 1/8. And this would be our final answer. Now, if you wanted to factor that, you certainly could. It's your option. Do you have to? No, you could leave it like that. But if you wanted to, you could factor out an 1/8 and make it look like this. If I was integrating, I would probably do that. Okay, but you don't have to. You can leave it like this. How are we? We okay? Now I need to, so the daily work has some different problems on it, right? There's always some different problems. I want to go over with you first before I give it to you because I think some students may be really confused. Does everybody have what they need? Okay, so like the very first problem on the daily work is asking you, it's this type, it's asking you to take this and transform it to powers of 1. We don't have a formula for this. What are we going to have to do? We're going to have to split it, aren't we? We're going to have to split it into sine squared, sine squared. Then we're going to have to use the formulas on it, right? And then there's the second one is like, I don't remember if it was, I think it was this, something like this. The second one looks something like this, or similar. What would we have to do here? We have to split the cosine, wouldn't we? We'd have to do the sine squared, and then cosine squared, cosine squared. Okay? And then use the formulas. And yes, it is going to be a load of fun, right? Because you're going to have to use the formulas multiple times. As you saw in this particular problem, I got them into single angles, but then I had to multiply them out, and then I got another squared, right? So this is going to be an adventure. Any questions?